Hey guys, this is Mr. Sal. We're going to look at some applications of the Pythagorean Theorem, specifically in word problems. Thanks for watching. Don't forget to like, comment, and subscribe. Alright, so the Pythagorean Theorem is if I have a right triangle, then I would take the two legs and square them. And if I add those two squares, then I get the hypotenuse squared as well. So this is also known as a squared plus b squared equals c squared. Let's look at what this is actually saying. Since it's the leg multiplied by itself, both times for the red and the purple there, it's just like we're creating a square out of these legs. And if I do that, then I can take the hypotenuse and square it as well, which means I'm actually am making a square out of this thing. So if I took the area of the leg, which would be the leg multiplied by itself, squared, and I added it to the other leg and squared that, then I would have the area of this green square. Well, if I wanted the length of that hypotenuse, then I'm just going to take that green area and square root it. So this is kind of an informal proof, which we did go over with some examples. So here is the objective for lesson 16. I can use the Pythagorean theorem to determine missing side lengths of right triangles. So this one is not looking specifically or just at the hypotenuse, but also legs now. So we got to be able to find the lengths of the legs. All right, this is in the packet. Given a right triangle with a hypotenuse with length 13 units and a leg with length 5 units is shown, determine the length of the other leg. So if I looked at this, I can see that length right there is 5, which would be this leg. And they're just saying that's the b value in the Pythagorean theorem. So there's a b value, and then the hypotenuse, I'll do it in a different color, there's the 13. So we're just going to expand that out. I got 5 to the power of 2, which is 25. Plus b squared equals 13 squared, which is 169. So to solve that equation, I would subtract 25 from both sides. And then I would get b squared equals 144. And then we just take the square root of 144. If you put that in the calculator, it will give you the whole value of 12. So the length of this leg is 12 units. We'll go into more detail on the next one. Use the Pythagorean theorem to find the missing length of the leg in this right triangle. So, again, you could use the squares on this one, but the difference is we're trying to find a leg. So I've got this leg, which is at 15. Then I've got this unknown leg right here, which I'm going to say is b again. And then I've got the hypotenuse at 25. So the Pythagorean theorem says if I square those two legs and add them together, I should get the hypotenuse squared. So this just becomes an equation that we need to solve, and by order of operations I would do the exponents first. So 15 times 15 is 225, and 25 times 25 is 625. Nothing else changed. So 15 to the power of 2 is 15 times 15, which is 225. And then I did the 25 to the power of 2, which is 25 times 25, which is 625. So I just evaluated the squares that I could. I don't know what b squared is yet, though, but we're going to figure that out. So to solve for b on this one, the next step would be to take that 225. So we got to get the b squared by itself. So I'm going to subtract 225 from both sides. We're subtracting the 225 to isolate b to the power of 2. So you guys learned this last year when solving equations, to isolate the variable. And it maintains equality, so it's also called a principle of equality. If I do something to one side, I've got to do it to the other side as well. So this would give us b squared equals 400. Very good. Now, I don't want b squared, I want b though. So what do? I take that 400 that 400 right there, and I just square root it. Because that 400 would be the area of that square if we were to draw the square. So how do we find the side length? We just square root the area. Now this simplifies also. Square root of 400 is 20. So that would be our final answer on this one. You have a 15-foot ladder and need to reach exactly 9 feet of the wall. How far away from the wall should you place the ladder so that you can reach your desired location? So just identifying the different parts on this. That side length right there is going to be part of that, or be one of the lines that makes up that right angle. So I know that 9 is a leg, that length. I've also got this length right here, which is unknown. We're going to call that the B value. So there's our other leg. And then the hypotenuse right here, which is given in blue, is 15 feet. So if I square the two legs and add them, I should get the hypotenuse squared as well. Process is going to work the same on this one as the last one. So to do this one, I got 9 squared, which is 81, and 15 squared, or 15 to the power of 2, which is 225. So to solve for B, I'll subtract 81 from both sides on this thing. Now to solve for B, I'll square root that area. So that's going to be the square root of 144, which, if you put it in the calculator, will give you 12. But be careful on this one, you guys. This is a word problem, so I'm going to have to label that as 12 feet. So this one, the answer, how far away from the wall should you place the ladder so that you can reach your desired location? 12 feet in this scenario anyways. Find the length of the segment AB if possible. Take 1 minute to do that with your partner. I don't know if this will help you guys out, but to find the length on this thing, what I would do is draw a right triangle right there. With that in mind, I'll give you guys another 30 seconds to see if you can figure it out. Let's do this one. Let's look at the red leg first. It has a length of 4, and the purple one has a length of 3. So if we use the Pythagorean Theorem on this one, I've got the 2 legs. If I square these two and add them together, then I will have the length of the AB segment squared as well. Alright, so this one is the hypotenuse, by the way. And 4 to the power of 2 is 16. 3 to the power of 2 is 9. And when I add these two together, I get 25. Now that would be like taking this square and finding its area. Yeah, because that would just give us the area on that one. So the actual length of AB on this one, which is the hypotenuse, is taking 25 and its square root. Now if you do that in a calculator, we'll give you just the whole value, no decimals, which is what we want on this one. So the actual length of AB is just 5 units. Given a rectangle with dimensions 5 centimeters and 10 centimeters is shown, find the length of the diagonal if possible. A diagonal for a shape is where we go from one corner to its opposite corner. So that's this length right here, which is also the hypotenuse of that triangle. So if you like this method, you can make the square right here, and this area would be 25. And then I can look at this 10 right here. If I made that a square, its area would be 10 times 10, which is 100. Alright, so if I made this a square over here, I would take the two smaller squares, 25 and 100, add those together, and I get 125. So the length of that diagonal there is the area, 125, but square rooted. And this we'll write in centimeters as well, so we'll label it the square root of 125 centimeters. Now there are ways to simplify this, but we're not worried about that right now. For now, this will do. Alright, looks like this one, number 5, does not give us any pictures, which is okay. A right triangle has a hypotenuse of length 13 inches with a leg and a leg with length 4 inches. What is the length of the other leg? Alright, on this one, we're going to need our triangle. So the red one's a leg, purple one's a leg. This will create a right angle. Then we got the hypotenuse. They told us the hypotenuse was 13 inches. So I'll label that. And one of the legs was 4 inches. So all we need to do is find the length of that missing leg. We use the Pythagorean Theorem on this one. I've got this leg, which if I square it and add it to the other leg, which I don't know its value,
what number
square
is
it, then I will get the hypotenuse at 13 inches, and that would be squared as well. Alright,
Is it right?
So 4 to the power of 2 is 16. 13 to the power of 2 is 169.
Whoa.
It is?
So 16 plus something squared is 169. If I want to solve this, I've got to isolate the b squared. So to do that, I'm going to have to subtract the 16 from both sides, just using principles of equality here. So b squared would be like the area of this square. So to find its length, we take that b value and the 153, its area, and we're just going to square root that. So that would be the length of the other leg, and this is in inches. Find the length of b in the right triangle below if possible, and it is possible. Alright, so right here I got this leg, which is at 4. And this is not drawn to scale. Alright, the area of the square would be 4 times 4, which is 16 square units. But this length right here, 11, that is the length of the hypotenuse. So if we square the hypotenuse, the area would be 11 times 11, which is 121 square units. What we want to find is the length of this leg, which is b. So we're going to turn it into a square. We can see that this purple square is much smaller than the green one and the red one. But also the red area is smaller than the green one. So it means that if I took the area of the purple square and the area of the red square, if I added those together, then I would get the area of the big one at 121 square units. So to solve for a on this thing, all I'm going to do is subtract 16 from both sides. And that gives me an area of 105. Now 105 is bigger than 16, but it's not drawn to scale, which that's okay. We know the hypotenuse square is going to be bigger than the 2, but it should be the sum of the 2 as well. So b is going to be the area of that square, the purple one, 105, but the length is going to be the square root of 105. So this is our answer right here. So when we find the area of one of the smaller squares, which is the leg squares, then all we got to do is subtract the area of the other square from the area of the hypotenuse square. Alright, here's our lesson summary then. The Pythagorean theorem can be used to find the unknown length of a leg of a right triangle and also the hypotenuse. An application of the Pythagorean theorem allows you to calculate the length of a diagonal of a rectangle, the distance between 2 points on the coordinate plane, and the height that a ladder can reach as it leans against the wall. There's a lot more other applications, but that's what we saw in this lesson. Alright, so this one we got to find the length of AB as shown. And it may look a little confusing at first, but if we just simply draw a right triangle like this, with our right angle being right there, then this hopefully isn't too bad. I can find the length of that red line by starting at A and moving to the right. 1, 2, 3, 4, 5, 6. So that length is 6. And the purple line starting here. 1, 2, 3, 4, 5, 6, 7, 8. Alright, and we'll find the length of this hypotenuse then, which is the distance between the points A and B, or the line segment AB. So, I've got the two legs, 6 and 8. When I square those and add those squares together, I will get the length of the hypotenuse squared. So 6 to the power of 2 is 36. 8 to the power of 2 is 64. So adding these two together, 36 and 64 gives me 100, which equals the hypotenuse squared. So if I just want the hypotenuse, C, I'll take the area of that square and square root it. This is a perfect square, which means if I put it in the calculator, it will come in as 10. So I know the length of that segment, AB, is 10 units. A 20-foot ladder is placed 12 feet from the wall as shown. How high up the wall will the ladder reach? Okay, well, we did one like this in the other one, but this is just a triangle, which they've shown here.
Can you go back to the other one?
So I see the purple line is a leg, and the red line also is a leg, and the blue line in this case is the hypotenuse. So the red square plus the purple square will be the blue square, and the purple one has an area of 12 times 12, which is 144. We'll say that this length is B because we don't know it yet. And the area of the hypotenuse square would be 20 times 20, which is 400. So the area of the red square is going to be the hypotenuse square, subtracting the other leg square, and that will give us the area of. Alright, so we got to go back, subtracting these, this would be 256. And the length of that line then would be the area there at 256, but we're going to square root it. So the square root of 256 is 16, and we'll label this one in feet. And there's our answer. Number 3, a rectangle has dimensions 6 inches by 12 inches. What is the length of the diagonal of the rectangle? Well, let's draw the rectangle first.
What's that in your bucket?
Alright, it said it has dimensions of 6 inches by 12 inches, and no, it's not drawn to scale, but this will do. We want to know the length of the diagonal, which goes from one corner to its opposite corner. So that would be this red line.
Wait, do we have to draw?
Alright, so this is our right angle right here. And what this also means is I don't really need this line, these two lines. So this gives me a right triangle with this leg and this one. So I'm going to take those two legs at 12 and 6. And when I square those and add them, I should get the length of that diagonal, which is the hypotenuse, as a square. So 12 times 12 is 144, and 6 times 6 is 36. So when I add those, I should get c squared. So let's go and see what we get from that. And this equals c squared. 180 is not a perfect square, so when I want that hypotenuse, or the diagonal of the rectangle we had drawn, I'm just going to take that area of the square and square root it. But once again, we should realize that this one is in inches, so we need to label it in inches. Square root of 180 inches. Here's the Pythagorean theorem to find the missing side lengths for the triangles shown in problems 4 through 8. Alright, well, let's use the Pythagorean theorem, so we won't be drawing any squares on this thing. Here I've got a hypotenuse, a leg, and a leg. So the leg is 12, and the other leg is unknown. It's B, and the hypotenuse is 13. If I square all these, and then the two legs squared, I get the hypotenuse squared. So let's show the work on this. So finally, B would just be that area at 25, but square rooted. And the square root of 25 is 5. So there's our answer for this one. Determine the length of the missing side if possible. I guess is number 5. All right, on this one, once again, we're given the hypotenuse right there and this side length. So we're going to solve for this unknown leg.
You okay, Brian?
So I've got the leg in purple and the leg in red, and then the green hypotenuse. If I square the two legs and add them together, I should get the hypotenuse squared. So let's show the work for this one, and then we'll solve this one. So if I just want the length of A, then I would take that area of 55 and square root it. So there's my answer on this one. Alright, determine the length of this missing side, which is B right there. And then I've got this length of the other leg in purple, and then the hypotenuse in green. So if I take the leg in purple, and the red leg is B, with the hypotenuse at 10. If I square those two together and add them, I should get the hypotenuse squared. 7 to the power of 2 is 49, and 10 to the power of 2 is 100. Then we'll subtract 49 from both sides. So if I do want just that length of B, then I'm going to take that area of 51 and square root it. So there's my actual answer for this one.